Okay, now let's look at a graph of secant. Secant and cosecant will be the same way. We're going to use our knowledge of sine and cosine graphs to do secant and cosecant. Secant is cosine reciprocal. So in order to graph secant, let's first graph cosine. Okay, so let's kind of review how would we graph cosine. Well, I'd mark out my period length to 2 pi. Negative 2 pi. And let's just go ahead and get a full graph of cosine on here. Cosine starts off the origin, then it returns to 0, goes down 1, back to 0, up 1. Same thing out here to the left. And I'm going to go ahead and just do like a nice dashed line. Okay, so there is cosine. Now the actual points that I want to plot are not these cosine points. They are the reciprocals of all of these cosine points, the reciprocals of all these y values, of all the points on this graph. Those are the ones that I want to see. So let's start plotting reciprocals. And the easiest place to plot to begin with are, so begin with the asymptotes. The reciprocal of 0 is undefined. So every place that this cosine graph crosses the x-axis, therefore has a y value of 0, reciprocates to undefined. Okay. Well, now, and we're going to do this just real rough. We're not going to plot real points. But now what we're going to do is just reciprocate all the curves between the vertical asymptotes. So, for example, the one point I will plot is just the first one here. The y value at this point is -1, and the reciprocal of -1 is -1. So that's a point on the graph. Well, I'm just going to take this curve and I'm going to flip it over. It's going to look kind of like that, kind of like a parabola. Okay. You know, if you think about it, you know, somewhere maybe right here there's a y value of a half that reciprocates to 2. There's a y value of a third that reciprocates to 3, and a y value of a fourth that reciprocates to 4. Negatives, of course, of all those. But it gives you this curve. Okay. Same thing here. I'm just going to take this curve and I'm just going to flip it over. Take this curve, flip it, take this curve and flip it, take this curve and flip it. There's secant. Everything else, please make dotted lines. The solid lines are the ones that actually plot on this function. The dotted lines do not. The dotted lines are just there to help us draw the graph correctly. Okay, that's it. So every time I see secant, I graph cosine, and I just throw in the asymptotes and then flip over all the curves. Okay, cosecant is the same as your secant graph, except cosecant is sine's reciprocal. So I'm going to begin by graphing sine. Okay, so sine's graph. We'll mark this out to 2 pi mark this out to negative 2 pi. The sine graph starts at the origin, goes up to 1, back to the origin, down 1, back to the origin. Okay, there's my sine graph. Now, just like with the secant, I'm not going to write as much of it down. I'm going to reciprocate everything. So everywhere that this crosses through the x-axis, vertical asymptotes, right there on the y-axis. Okay, there's all my verticals. I'm going to take all those curves between the verticals and I'm going to flip them all over. Really, this is an exercise in being able to graph a sine graph. If I can graph by hand a sine curve, then I can very easily get its cosecant graph by just reciprocating everything. Okay, let's see a couple examples of graphing a secant function. Actually, let's just kind of speed it up and let's just do maybe one of these two. Let's just do the first one here. I see y equals secant 3x, so I'm going to begin by graphing y equals cosine 3x. I'm going to take just the reciprocal function, cosine. I'm going to deal with that one. And for this one, it has an amplitude of 1, has a period of 2 pi divided by 3. Okay, so I'm going to come out 1, 2, 3, 4 tick marks, drop my period, 2 pi over 3. 1, 2, 3, 4 tick marks, that's negative 2 pi over 3. It's cosine, so it starts off the origin, has an amp of 1, so 1 unit above and below. Whoops, I missed it. Let's back that up and let's use a different color here. Okay, so we're looking at the green color, ignore the black. Okay, the asymptotes are where this graph crosses through the x-axis. Okay, and now to actually draw the graph we're after, we're now going to reciprocate all those curves. And there's secant 3x. It looks like secant x that I drew before, but what's different is the scale on the x-axis, of course, has been changed. Okay, if you want to do this one on your own, go ahead. I'm going to skip it though and move on to the last slide. Okay, let's look at a cosecant graph. Again, anytime I see cosecant, I'm going to instead graph its reciprocal, which is the sine function. And if I have a sine function, I'm going to look for the amplitude and the period. Okay, so there's my amp and period. So, come up here, I'm going to go out 4 tick marks and drop my period. I'm graphing sine. Sine starts at the origin, goes up 1, back to 0, down 1, back to 0. Okay, and the same thing on the other direction. Okay, so it looks like that. We're going to throw in our vertical asymptotes. This one's right on the y-axis. Okay, and let's put in the curves. Okay, how about a question I haven't asked yet for the secant and the cosecant, just to kind of wrap up. For this graph here, how many periods do you see? The incorrect answer, what I would hear some students say, is that there are 4 periods. But that's incorrect. A period length is what you see before you see it again. It's so here is a period. Everything's different, right? Then there's the same image again. So it's these two, and then it's repeated over here, and then it would repeat again. So how many periods do we actually see here? Correct answer is there are 2 periods. Even though there's 4 kind of little parabola-shaped curves, there are really just 2 periods showing on that graph.